The next pandemic is not a question of if, but of when.
Throughout history, pandemics have swept around the world, leaving devastation in their wake. What are we doing to prepare for the next one? Hello, I'm your host, Alice Allen, and in this series I'll be going behind the scenes at WHO and some of the European region's major public health institutions to understand what the most likely causes of future pandemics could be and what strategies are in place to avert them. I'll talk to the experts applying the lessons of previous pandemics and focus in on the systems in place to spot threats and reduce their impact. I'll speak to the legion of public health experts, quietly working away, getting on with the not very glamorous but incredibly important work of emergency preparedness. Experts in surveillance, genomic sequencing, epidemiology and more. The people who are containing outbreaks and laying the groundwork to mitigate the effects of pandemics, not if, but when they occur. Episode 4. Influenza, Past, Present and Future.
I had a little bird. Its name was Enza. I opened the window and in flew Enza.
That sweet little rhyme has a sinister story. It was recited by children between the years of 1918 and 1920, during the first of the 3 influenza pandemics that occurred in the 20th century. A pandemic that is estimated to have killed over 50 million people. I spoke to Richard Pebody, Director, Clinical and Emerging Infections of the UK's Health Security Agency, and a former WHO Europe colleague of mine, to find out what we know about the 1918 influenza pandemic.
We know quite a lot about events that happened then, really through the forensic work, recent work of epidemiologists, virologists and historians. So we know now, for example, that the 1918 pandemic was definitely caused by an influenza virus. We even know which subtype it was. It was an H1N1 subtype. We actually even know that the sequence information on the virus, which is amazing really when you think how long ago it happened. We also know that it was first recognised in the spring of 1918, so that was actually the final year of the Great War, the First World War. So it was a time of a lot of movement and obviously conflict. We also know that it spread rapidly across Europe and North America.
What do we know about the symptoms of that outbreak?
There were some unusual presentations, and that it's clear, probably in retrospect, that bacterial superinfection was a particular feature, at least in some cases. And we also know that it wasn't just one wave, but several pandemic waves in the subsequent 2 to 3 years afterwards. But of course, there's still a lot we don't know, and we don't know actually where it originally arose from. There's been a lot of speculation, but we don't really know where it started.
We'll hear more from Richard later. The Division for Influenza and Other Respiratory Viruses at the Robert Koch Institute in Berlin focuses on the analysis of influenza viruses currently circulating in humans. It's a National Influenza Centre, which means that the data it collects feeds into the regions and into global surveillance and understanding of influenza. Dr. Thorsten Wolff is its director. I spoke to him to understand what we've learned about influenza viruses in the last 100 or so years.
During the large outbreak in 1918, there were lots of debate what the causative agent is. People living 100 years ago didn't know that the disease was caused by a virus, by influenza viruses. If you read the literature from the time, there were large debates whether that is being a virus or being a bacterium, and there were arguments for both possibilities. The concept of a virus was pretty young. It was invented by around 1900, working with tobacco mosaic virus. Now, at the time, colleagues working at the Robert Koch Institute, for instance, took swab samples from patients and put them on agar plates, and they found all sorts of bacteria. So there was lots of frustration, actually, that this could not really be pinpointed at the time. So at the time, the methods were not developed to isolate viruses, and it took until 1933 before human influenza viruses were isolated.
What have scientists learned about influenza in the last 100 or so years?
Since the time, we have learned about the genetic material of the viruses. The progress in the characterization has certainly been largely facilitated by the molecular biology revolution in the 1970s. So sequencing the genomes and finding 8 different single gene segments explained the ability of the viruses to exchange the gene segments. So if 2 viruses infect the same host cell, there can be variant viruses in the progeny, and that could confer new biological properties like belong to a new subtype. We also, of course, have to name the development of influenza vaccines starting in the 1940s. And also the development of robust antivirals.
One of the big breakthroughs in the understanding of the influenza that caused the 1918 pandemic came about in the 1990s, when an American pathologist called Jeff Taubenberger was able to apply new methods to the study of lung tissue obtained from soldiers who had died of the disease.
He took up the challenge to try to isolate with the methods at the time, so PCR was new, to amplify genetic material from the virus that he suspected would be in these tissue blocks. This was really a heroic work. He could find not complete virus or gene segments, but really tiny pieces of it. And amplifying these small pieces and then assembling the hemagglutinin gene segment took quite some time, but he managed to do that. So the virus from 1918 was a predecessor from the viruses isolated in 1933. And from the virus sequences of that, one could say that was the one closest to the one circulating in birds.
In the search for more samples, Jeff Taubenberger then went to Alaska. In a remote Inuit village near the town of Brevig Mission, he visited a mass grave full of local people who had died in the 1918 pandemic. In it, he found the body of a very large Inuit woman who had lain under more than 6 feet of ice and earth for more than 75 years. The permafrost, plus the woman's ample fat stores, meant that the virus in her lungs was so well preserved that it provided enough material to sequence the complete genome of the virus that had caused her death.
And again, the gene segments turn out to be related to viruses circulating in birds, but nothing spectacular that could be just derived from knowing the sequence. In the late 1990s, there were parallel developments. You could reproduce an influenza virus based on the sequence and then use so-called reverse genetic methods to reconstruct the virus. And that was also done in high biosafety level laboratories. And there were some studies conducted in animals and in tissue cultures. And there it was found that this virus certainly had a pathogenic capacity that exceeded much the ones that we know from seasonal viruses from today.
Monitoring the evolution of influenza continues to be an important part of the work done at the Robert Koch Institute.
At the Robert Koch Institute, we run a sentinel system in which we include 160 primary care practices placed all over Germany. And from these practices, we receive on a weekly basis samples from patients who seek care for acute respiratory disease. And so the samples are being sent here, and we are looking in these samples by PCR methods. From the ones where we find virus and where we can then explain why these people had to go to the doctor. We sequence the viral genes, grow the virus from these samples in tissue culture, and then analyze them.
The National Influenza Centre in Germany is one of 151 centres based in 129 member states that form part of the WHO Global Influenza Surveillance and Response System, or GISRIS. GISRIS is crucial for understanding what flu's next move will be.
The next station is King's Cross St Pancras. Change for the Northern.
I think the chances that disease X will be an influenza virus are probably greater than any other known pathogen group that I can think of.
Nicola Lewis is director of the Worldwide Influenza Centre at the Francis Crick Institute. As one of 7 WHO collaborating centres on influenza, it receives samples from national influenza centres, like the one Thorsten Wolff works in, and takes up the baton of analysing them to understand their genetic sequencing and what kind of immune response they produce. Then, twice a year, the WHO collaborating centres that are part of GISRIS come together to discuss their findings, identify which candidate vaccines might be useful in case of a pandemic, and decide on the changes that should be made to seasonal flu vaccines.
So we spend a week looking at the data packages that we have, understanding the data that's been presented, and then we make recommendations for the human seasonal influenza strains. So these are the viruses that circulate routinely every season in the human population. And what we do is we analyse the data to make sure that we're making a recommendation for the most effective vaccine to use for the upcoming flu season.
What's the difference between seasonal flu and flu with pandemic potential?
So seasonal influenza viruses are viruses that once caused a pandemic and now caused epidemics during the year. And the key thing about seasonal influenza viruses is that we, as a population, already have prior immunity to a greater or lesser degree. And so that's why they become seasonal, because they can still transmit, but the impact of them transmitting is not quite as great as it was when they were initial pandemic. Pandemic viruses are often, or pandemic threat virus is often one of a different subtype. And a subtype is the combination of hemagglutinin and neuraminidase that stick out of the side of the virus that our immune system recognizes. Now, most people do not have prior immunity to many of the subtypes. We only have prior immunity to human seasonal H1 and H3 subtype influenza strains.
I don't think I realised that seasonal flu changes so much.
So flu changes constantly, and our job as collaborating centres and underpinned by the huge amount of work that the National Influenza Centres undertake is to make sure that we understand how the viruses are evolving. And when we see evidence that the vaccine might be less effective in the upcoming season, then we make recommendation to change. Flu vaccine is very safe and very effective. And even in a year when perhaps evolution has happened a little bit after the recommendation, it's certainly a very safe and very effective product. And for people, particularly people who are most vulnerable to flu infection, the flu vaccine is an essential part of our armoury in helping to protect the human population. Unfortunately, flu is very difficult to predict. And sometimes the evolution is faster in some seasons than it is in other seasons. So it's really our job to stay on the ball and try to keep up with the evolution of these viruses to make sure that we're making recommendations for the most effective vaccine that we can.
Currently, what's the lead-in time for developing a new candidate vaccine?
The lead-in time for seasonal vaccine changes is really set through the annual life cycle. So there is a reason why our recommendation happens in February, and that's because it takes nearly that amount of time for the vaccine manufacturers to change the strains in the vaccine and manufacture the vaccine and fill the vaccine into manufactured distribution vials and then get it out to the customers to get into people's arms. Now, for the pandemic vaccine side of things, we really would have an equivalent lead-in time, because it takes that long, even for a pandemic strain, for it to go through the safety process and to be used and to be manufactured and to get into people's arms again. So you're really looking at the moment as a similar kind of time lag between either a pandemic starting and or a change in human seasonal recommendation. So it's not immediate, and it does take time. And so that's why it's also important that we assess other aspects of risk mitigation when we're understanding our genetic characteristics, for example. Because if we were to have a pandemic, we'd want to use all the resources at our disposal to fill that gap between detecting a pandemic and having a vaccine ready to go into people's arms.
How would you say your work fits into pandemic preparedness?
So as I've mentioned, we have this GISRIS network, which is globally distributed. And they are not only on the lookout for changes in human seasonal viruses, but they're also on the lookout for any potential infections of the human population with animal influenza viruses. So they are really our eyes and our ears about what is happening on the ground. And if they do detect a human infection with an influenza virus that's been circulating in animals, then the whole of the network come together to understand this particular infection, to analyze the virus that might have caused this infection, and then to make sure that we are adding to our armory of candidate vaccine viruses of zoonotic potential. So these are viruses that could potentially be the next pandemic. We have a list of those that are available for manufacturers to start work on, so that we have this pipeline primed and hopefully we never need to use it.
Given the changes that you've seen since 2020 and the widespread infections and mortality in wild birds, domestic birds, and also in mammals, does the global spread of influenza through zoonotic infection, does it keep you awake at night?
I don't think it keeps me awake at night. And I think that's because I have every confidence in the GISRIS network, but also my team at the WHO Collaborating Centre, that we spend every hour of our working day trying to do our very best to understand the risk, to communicate the risk, and to characterize these viruses as accurately as we can. And I think that's the strength of the GISRIS networks, that we really have excellence within it where we can pull together so that we stand ready. I don't underestimate the threat from influenza, however, and the impact that it can cause on people's lives, and also the impact it can have on food security, because many of these viruses in animal populations kill the animal that they infect, particularly these highly pathogenic avian influenza viruses. So I think from that standpoint, we have a very central role to play, not only in trying to protect human health from the next pandemic, but also in supporting communities around the world to have better food security, to protect animal health as much as we're protecting human health. So I think there's a lot of work to do from the public and the animal health side, collectively, scientifically, and across all regions of the world, to make sure that we are ready and that being ready is an equitable process. I think GISRIS has really shown the way in how a network can operate. And even though the last pandemic wasn't flu, many of the people in the GISRIS network pivoted to address SARS-CoV-2 instead. That said, I think there needs to be a prioritization at the regional and sub-regional level to build partnerships, trusted partnerships between animal health, between public health, and within regions where you might have an emerging disease that then spreads a little bit more regionally, to build those trusted partnerships with all stakeholders included, and to build those partnerships during peacetime, that if there were to be an event, those trusted partnerships are already in place, the collaborations are already in place, perhaps there's been sharing of advice and expertise previously, and everybody is on the same collective page about how they can work cohesively together. And so I think from pandemic preparedness side of things, it's imperative that we work collaboratively and in a trusted way going forward, because we aren't going to be able to do the best for public health in the future unless we collaborate together for global public health. And as soon as you have a virus get into the human population that starts to acquire the ability to transmit from one person to the next, then you need to be acting very quickly to contain that situation, to be able to identify that it's happening. And so that's really coming back to the idea that we really need to be building this resilience now.
Are we prepared for the next pandemic?
Whether we're ready for disease X yet, I think that's open to conjecture. I think we've learned that GISRIS is a very strong network, has huge and untapped power in terms of its ability to respond to disease X or to the next pandemic or to the next flu pandemic. So I think we're very strong from that position. I think we should perhaps reflect on aspects of sharing information in a real-time basis better and more inclusively than perhaps was done during the COVID pandemic. And so I would really put a plea to the global community to one of the biggest lessons is to build on these trusted and collaborative partnerships, but particularly in sharing near real-time information. We have the technology to sequence. We have the technology to diagnose, but there is still a lot of work to be done to build trust to share those pieces of information with the international community rather than wait for it to perhaps turn up somewhere else, by which time the pandemic could well have started. So I think my message to international communities is in some ways we have to set aside our reticence. We have to set aside our parochial concerns and remember the impacts and the devastating consequences of a global pandemic from whatever disease agent it comes from, and try to rise above those parochial issues to really make sure that we are trying to do the best for the future of public health.
Let's come back to Richard Pebody. What lessons from the 1918 pandemic are still relevant today?
It highlighted really what a huge impact respiratory pandemics have the potential to cause. I mean, the virus spread very rapidly around the world, a lot of it aided by the movement of people related to the end and the aftermath of the First World War. And it really infected a large proportion of the world population. We also estimate that perhaps 50 million, maybe more, people died because of the 1918 pandemic. And that's actually more than died through the entire World War.
That's a really sobering thought.
I think the lesson for us there is that we really need to make sure that we prepare properly for the next respiratory pandemic, whenever that might happen. The second point is around equity and the fact that certain groups were disproportionately affected. We know, in particular, it's very well described that in 1918 that young adults, particularly males, were at increased risk of severe disease and death. And it's thought that was linked to the often overcrowded military camps where young men were being kept and looked after during and after the war. And that provided increased opportunity for spread both of the virus and also, obviously, of bacterial infections as well. But we also know that there was much higher mortality rates in economically deprived communities. So it was seen particularly in Indigenous people and in lower income settings.
And unfortunately, we see that played out throughout history.
Unfortunately, the pandemic impact is often higher in groups where access to things like healthcare and preventive interventions like vaccination are not as good. And we need to ensure this is tackled better in the future. The third point, I think, relates to the communication point and the issue of ensuring that accurate information is shared in a timely way. And I think one of the points that is important to highlight around 1918 is that it's often referred to as Spanish flu, as actually the first cases were reported from there. But in fact, the cases were occurring already elsewhere in Europe and North America.
So why was the finger pointed at Spain?
Because of war censorship at the time, that meant that reporting was often restricted. Spain, however, wasn't part of the conflict and had much more access to open information. And so, unfortunately, were the ones who were blamed for being the source of the infection, at least by some places. And I think this highlights again the lesson here is the importance of ensuring that early, accurate information is shared. And that helps other places, other countries to optimize their pandemic response and hopefully ensure that they're as ready as possible. And of course, much of this is now enshrined in the updates around the international health regulations. And of course, the other point here is the one of avoiding social stigma by linking places, people to viruses and infections.
Finally, is there anything we can learn from the 1918 to 20 pandemic about how to combat future pandemics when they occur?
Now, of course, back in 1918, 100 years ago, viral vaccines, antivirals, antibiotics just weren't available. They hadn't been developed to prevent and treat cases. But there were still some interventions available to be deployed. So, for example, non-pharmaceutical interventions were actually adopted in some places. So use of things like case isolation, masking, school and workplace closures, they were actually tried in some places and did seem to reduce transmission and impact on healthcare systems. So I think the lesson 100 years later, where we're obviously in a much better position in terms of our access to technology and the ability to have and to develop viral vaccines, antivirals, antibiotics, it's important we continue to invest in these. But I think the other key point, of course, is this critical issue to ensure that there's early access to these pharmaceutical interventions for all eligible groups across all member states.
In future episodes, I'll talk to experts who are tracking disease outbreaks, trying to understand them better, and preparing for future pandemics. Not if, but when they happen. Health in Europe is produced by the World Health Organization. Music for this episode is by Ben Howells, Richard Dutnell, Gavin Linehan, Alex Atwood and Chris Tolley. Sound engineering is by David Barrett. My name is Alice Allen. Thanks for listening.